apologize if I cough a lot. I'm a little under the weather for the last couple of days, so still trying to bounce back.
All right, so you guys got 1 and 2 done?
Mm-hmm.
Yep. Yeah, chicken.
All right, so we find the margin of error for 90% confidence interval with the standard deviation of sigma 50 and sample size 25, around to 3 decimal places.
I'm gonna copy it real quick.
So for this one, which equation do we use since we don't have an x bar?
So for this one, the margin of error is just. Never mind, I don't know what I'm talking about.
It's 1.645 times. That's not our standard deviation. Yeah. Times 50 divided by 25. Everything squared.
Say that one more time.
So is it the 1.645 times 50 divided by 25 squared?
Is this the one where we have to plug it into the applet, get the z-score, then it's the z-score times the deviation?
Yeah. Yeah, the z-score is 1.645.
0.645 on that one.
And then the standard deviation is 50, so we multiply the z-score by that, correct?
Correct.
And then we divide it all by our sample, which is 25.
It'd be the square root of the sample.
Is it square root of sample? Is that where I messed up?
Yeah, that's square root.
Okay, square root of sample. Divided by square root. 25. There goes my internet cutting out on my other computer. So quality. So then do we square it after that, or is that complete?
I believe that's complete. I'm pulling up
So is it 16.450?
That's what I was thinking, because I just got 16.45.
Yeah, that's what I got. I figured we had to add a 0. We good on that, I guess?
Yep.
Alright, so number 4, which of the following statements is true? I picked X bar as the point estimator. Oh wait, no, not point. Hang on. Did you guys watch the video for this one? Like, is parts 1 and 2?
I didn't. Not this time.
I think it had... Anyway, I put C, but I don't know if it's A. But I'm pretty sure X bar is the point estimator of the mean, the population mean U.
That sounds right, but I can't figure out where it was that I read that.
Yeah, I think it talks about it right under point estimators, but I'm trying to pinpoint the exact location. Oh, the statistics above are called point estimators because they're just one number on the number line, that is used to estimate a parameter. Parameters are generally unknown values. Think about the mean. If U is unknown, how do we know X bar is close to it? You guys see where I'm reading?
Yeah, I got it right
Okay.
here.
I think it's in there somewhere. I'm still reading it. It mentioned point estimator, so I'm not sure. I think, is it X for U or U for X?
That's what I'm trying to figure out.
I'm pretty sure from the videos it was X bar is close to U, because U is the whole population, right? And X bar is just the sample mean?
Yep.
Yeah, so X bar being the sample would be the point estimator of the whole population, U.
That sounds right.
Let me know if I'm going too fast.
Not very good.
I have to be somewhere at 6:30, but I can cancel if we have to stay here longer.
Yeah, that's right. If you go to like the practice problems for part 2 of the preparation assignment, one of the questions, what is the point estimate for the population mean? And it's the X bar. So you are right.
Sweet. All right. So Gina wants to construct a 95% confidence interval for her GMAT score. She knows the standard deviation is sigma 113. She collects a simple random sample size of 64 and computes X bar 526. With this information, answers the questions 5 through 8. Okay. What is the lower limit of this confidence interval? Got to pull up my equation. So
it's X bar minus V times sigma over square root of n. That's what we're looking for, right?
yeah. So X bar 526 minus 1 point. What is it? Our sample is 95%.
Yeah.
1.960. And then that's divided by, or no, multiplied by sigma 113 divided by,
Yeah, 498.315.
wait, what did you get?
498.315.
I think I totally
Yeah,
messed that up. Hang on.
37.
I got like 7,000. Let me plug it in again. 526.
All I did is I computed the margin of error, so I had the z-score that we got from the probability applet.
Oh, that would make more sense.
So the z-score I got would have been 1.96. I multiplied that by sigma, then I divided by the square root of n, and then I just let my calculator plugged in 526 minus the answer of that.
So wait, what'd you get one more time?
498.315.
27.685. Yeah, 498.315.
Yep.
I can agree with that.
Cool. And I think 6 is just asking for the upper
Yeah, so it's just plus now. So 526 plus 27.685. I got 553.685.
Agreed.
All right, cool. Okay. We're good so far?
Yep.
All right, what would happen to the width of the confidence interval if Gina increased the sample size? Wouldn't it decrease? Because as far as your sample goes up, everything else becomes normal or gets smaller, correct?
So what happened to the width of the confidence interval? So if you had smaller sample size or increased sample size, your margin of errors would be smaller, so your range would be smaller. So yeah, it should be decreased.
And then, sorry, these are like all from the video. Like all these answers are really coming from there.
Lead the way, Lance.
Yeah, I really appreciate those videos, teacher. I hope you heard that. Okay. What would happen to the width of the confidence interval if Gina changed to a 99% confidence interval? So the wider the interval, doesn't that increase because the width's going to get bigger because your confidence is higher?
Yeah, you're gonna get a larger z-score, so it'll make your whole equation larger.
I agree. You good with that, Brooke?
Mhm.
Sweet. Okay. Bright Bulb Light Bulb Company, so smart, is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is sigma 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? Oh, shoot.
So 0.95. So z-score of 1.960. This is just algebra then, just working it backwards to get sample size.
So we're looking for margin error of 50.
50.
So basically, it's 1.96 times our standard deviation, right?
Yep.
400, which gives us 785 divided by 50? No, this is where I'm lost.
Yeah, divided by 50.
Is it 50?
Yep. And
Okay.
then we'll have to square that to get rid of the square root on the sample.
And so that gives me 245.8624.
So it should be 246 then, rounded
Yeah.
to the full number.
That's what I got.
You double check that real quick.
Yeah, no problem.
So 1.96 times 400. That's going to be divided by 50. That's going to be equal to the square root of the population. So we need to square that. 245.86. Okay. 246.
You good there? Everyone on the same page? Any questions? All right. The mean salary of actuaries is 100,000. Standard deviation is sigma 36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it's higher or lower. You set up a hypothesis test with a level of significance of alpha equaling 0.05. There's your original and then the not equal to. You collect a simple random sample of N36 women's salaries and find that X bar is 111,000. Use this information. Ooh.
Remember that formula?
Yeah. So X bar, or wait.
I'm going back to it real quick because I don't remember it.
Yeah, give me a sec. I gotta take this call. Hey, dude, what's up? I'm in a group meeting. Can I call you back in a sec? Oh, shoot. Yeah, I might do that. See you, dude. Bye. Okay, sorry. So the equation sigma. So 36,730 divided by square root of 36 times 1.96. And our x bar. You get 99,001.
Give me 1 second. So what did you do exactly?
So, I mean, I just did the equation like it shows the, how I started. I did sigma divided by the sample, so 36,730 divided by root 36. And then I took that, multiplied it by 1.96 because we're doing 95% confidence interval. You still following me?
Yep, that's what I missed on that one.
Okay.
1.96.
Hey, Lauren, you mind calling the guy at the gym? Tell him we won't be able to make it tonight. Okay. We're gonna go play frisbee at the stadium. Dustin and all them are playing.
I don't know. So, I'll definitely go.
Yeah, I mean, if not, you can stay here. What'd you guys come up with?
So what is the lower? I got $99,001 essentially.
You got 0.5, then round up to to 2 essentially.
Yep.
Sweet deal. All right. And then we'll do the same thing. 11 plus 111,000 plus the 11,000. Which gives us 122,998.
1 second, I lost my place. Would you get one more time?
122,998.46.
So just 122,998.
Yeah, 122,998.
But thank you so
When's he back from his trip from Arizona?
Oh, actually, when are you back from your trip? Okay, well, we probably just order or schedule for them. That works. Yeah.
All right, so 12.
What time are you good?
There are 3 requirements that need to be checked when computing a confidence interval for a mean. They are: simple random sample is drawn from the population, X bar is normally distributed, sigma is known.
So there are 3 requirements that need to be checked when computing a confidence interval for a mean with sigma known. 1, a simple random sample is drawn from the population. 2, X bar is normally distributed, and 3, sigma is assumed to be known.
The above.
Is it all the above?
Yeah, that was
Yeah.
right there out of the book.
Where was that at again?
4.4 under requirements on lesson 10.
Oh, there it is. Nice. Okay. You want to read through the answers real quick? All right, so 1 and 2. Oh, wait, any questions before I read through them?
Yep.
All right. 1 and 2, I hope are true. 3 is 16.450. 4 is X bar is the point estimator of U. 5 is 498.315. 6 is 553.685. 7 is decrease. 8 is increase. 9 is 246. 10 is 99002. 11 is 122998. And 12 is all of the above.
You said 9 was 246?
9 was 246. Did I put that in wrong?
No, I did.
Is that what you got, Brandon?
Yeah, 246.
Okay. What? Is that my internet? Unable to submit exam. What the heck? Communication failure.
Man. No luck at all, it seems like.
For real, though, what the heck? That's some quality iLearn right there. Yep. Yes, sir. Were you guys able to submit?
Yep, mine went through just fine.
What'd you get? 1,000,000?
So we were right on everything. Just your internet's not working, apparently.
Seriously? What the heck? Unable to submit exam. Click OK to retry. Details. Communication failure. Okay, that seems legitimate. Ugh.
Oh, man.